Hello class, my name is Jimmy Joseph and I'll be doing my presentation on the article An Overview of Data Warehousing and OLAP Technologies. An outline of this presentation will be the motivations behind this concept, basic concepts, problems and challenges derived from data warehousing and OLAP technologies, proposed approaches and solutions, and then the conclusion. The first section I'll be talking about are the motivations. Data warehousing and online analytical processing, also known as OLAP, are two of the most important factors when it comes to helping an organization or a person make an analytical decision based on historical data. Both concepts have grown tremendously over the years across industries, and in the article that I read, an overview of data warehousing OLAP technology, it talks about a couple of things such as the background tools for extracting, cleaning, and loading data into a data warehouse, multi-dimensional data models typical of OLAP operations, front-end client tools that are used for querying and processing the information, tools for metadata management and managing of the warehouses. There will also be a section during this presentation in regards to the issues that the database community has faced with this topic. To start off with, we first must ask ourselves, what is a data warehouse? According to Amazon, a data warehouse is a central repository of information that can be analyzed to make up more informed decision. Data flows into a data warehouse from transactional systems, relational databases, and other sources, typically on a regular cadence. Business analysts, data engineers, data scientists, and decision makers access the data through a business intelligence tool, SQL client, and analytical applications. Basically, this is a general definition of what a data warehouse is according to Amazon, but to put this in a simpler way, a data warehouse basically is a system that is used to collect and hold information that is basically done within a company. So let's say, for example, Amazon themselves, any purchases that you perform on Amazon goes into their database and then it's put into subsections to where all their information is put in there. And then on the other side, that's where they'll have their business analysts and data engineers go in and take that information and in a established database set up for them to perform analytics on that and probably flow that information into analytical tools such as Tableau or Power BI or any other tools that are similar as such. Now, the next question that we must ask ourselves is why data warehousing is important. We live in a time frame of information, and big data has taken over industries by storm. Right now, we are dealing with an issue of big data. Companies can collect and store massive amount of data, and the next thing for them to do is to be able to make a meaning behind this data. This is where data warehousing comes into play. Data warehousing allows for a user to be able to quickly access critical data in one place for faster decision-making skills. Just like I talked about before in the example of Amazon themselves, Amazon deals with a extreme amount of data inflow into the company as well as data going out to users as well. So to be able to manage that information will take massive amounts of server space and a ton of database tables. So designing a data warehouse is extremely critical in being able to establish a place to quickly go to the exact tables that you need to go to and be able to display that information to decision makers very quickly. In the article, an overview of data warehousing and OLAP technologies, there's a section where it's said that in 1995 to 1998, there was an expectation of the data warehousing market to grow from 2 billion in 1995 to 8 billion in 1998. I did a little bit of digging and I found out that as of 2019, that number went up to $21.18 billion and is projected to grow even further as to $51.18 billion by 2028. One of the key takeaways of a data warehouse is actually through the use of a online analytical processing, which is OLAP. OLAP is one of many different ways that you can deal with a multi-dimensional database. In the next couple of slides, I'll be going over a little bit more information in regards to that. Basic concepts. This picture shows you from end to end how a data warehousing architecture kind of starts. Right, in the beginning section, you have your external resources or operational databases or data sources. So any type of place that you get your information from, whether it be user inputted information, whether it be information that is already put into a website, such as in regards to Amazon's case, an external resources being a user putting in their personal information to establish an account with the system. An operational database system can be all the different products that Amazon holds or services that they have. This database would kind of hold all that information or any other external data sources that they'll actually use. The next step in that process would actually be the ETL process. The ETL process is where a company would basically extract data from one of these sources, transform it into a way to where it is able to put it into the established setup of their data warehouse, because each data warehouse is going to be designed in a specific manner, and then load them into their to the data warehouses and refresh and kind of go through that process once again. There's also a monitoring and administration period to where you kind of check there's people that checks the data prior to going in, but this is basically the beginning processes before it goes into a data warehouse. A data warehouse is, like I said, set up in a way to where all the data itself is located in one location. Data warehouses can actually be broken up into data marts. Within each data mart, it could be a subsection of the data warehouse, whether it could be financial data in right here, operational data here, as well as user information here, all separated into their different locations. So if a data engineer or data scientist wants to pull information from a specific location, they can go to an individual data mart versus working with the overall data warehouse itself. And then the next step would be the OLAP servers, where it takes all that data within a data warehouse, puts it into a server that is multidimensional to where it has historical data. One row being, let's say, for example, it could be the individual products that they're selling, and going across could be the days of the week or the months, the time series of when these products are sold. And then from there, from an OLAP server, it takes you over to the last step, which is the tools that you can use when it comes to data mining, querying reports, or any other type of analytics that are going to be performed. As discussed in the previous step-by-step diagram of a data warehouse architecture, the first step, as said before, is collecting and cleaning the data and putting them into a predefined database architecture. As I said before, this process is known as the extract, transform, and load ETL. In recent years, there's been many advancements when it comes to this process. A lot of times beforehand, a lot of the information was checked manually. However, with the changes that we've made and the different software tools that we've been able to create, there are different applications that could be used to be able to help with the ETL process. Um, right next to it is the example of a couple of ETL applications or data management applications that are quite popular nowadays. You have the IBM Data Stage, Oracle Data Integrator, SAS Data Management, Hadoop, ASW Glue, and Google Cloud Data Flow, to name a few different resources. Once the information has been loaded into, cleaned up, and processed, transformed, it is then loaded into a data warehouse. A data warehouse, as I said before, is created to help establish a all-in-one source of data to where information can be developed and altered to help create a business decision. When dealing with the data warehouse itself, it could be multi-dimensional, and to deal with that very quickly, we use OLAP technologies. Using this method, a user can quickly aggregate data and perform any type of data mining or analytics when it comes to data warehouse. Here's a few different schemas of what a table can or a database can be set up when it comes to OLAP, performing OLAP processes. The first table right here is the star schema. So basically what it has is just one fact table, and then there's several different tables that connect to the fact table and in the database. And then there's a little bit more complicated snowflake schema, where each fact table has a fact table has a dimension table, and then those dimension table also have their own subdivision tables. So going back to the star schema, let's say for example your fact table is a product. You could have the fact table could have a primary key of the product name, description could be one dimension. The delivery date of that product can be another dimension, and the method of shipping and all these other things could be different dimensions of those things. For the snowflake schema, it could be the same concepts where you have the product and everything like that, and then one of the dimensions could be the delivery format, and the subdivision of that delivery table could be something along the lines of a different sub company that they could possibly work through, and that's kind of how that snowflake schema would probably work. As discussed before, OLAP technologies are basically used to be able to aggregate and very quickly look at that information. When it comes to OLAP technologies, one of the most popular used front-end application to support this is actually the spreadsheet, similar to as Microsoft Excel. There are a few OLAP operations that can be done using spreadsheets, such as pivoting, roll up, drill down, slice and dice, and more. The operations are used to quickly and effectively aggregate the data for further analysis. This image next to that is basically kind of just showing how a multi-dimensional database would actually look like. The previous slides showed the different schemas, and this kind of shows you a more visual look on how that would actually look. So if you look at the actual cube, you have the different cities in the top section. Then going down the cube, you see the different types of products. And then going across the board, you can actually see the actual dates. And that's kind of how a multi-dimensional database is kind of set up. The dimensions themselves is the product, the city, and the dates. And they can kind of be broken down into their own subcategories and go further down like that. And using OLAP, such as using a spreadsheet, you can kind of make a pivot table or aggregate the data in whatever way you see fit to be able to have further data to make a better business decision for the company or project that you're working on. Moving on, we'll be talking about problem definition and challenges. Data cleaning is a problem that is reminiscent of heterogeneous data integration, a problem that has been studied for many years. But here is the emphasis on data inconsistency instead of schema inconsistencies. Data cleaning, as indicated, is closely related to data mining, with the objective of suggesting possible inconsistencies. When it comes to the data cleaning process, a lot of things goes into play there. Ensuring that you have correct information, the correct spelling, whether it comes to correct location or um, data validation. These are extremely important when it comes to creating a data warehouse because if you have inconsistent data or unclean data, it will definitely cause complications when it comes to performing the analytics later on. This chart kind of just shows you the steps when it comes to the data cleaning process, when it comes to importing the data, merging the data sets together. If you have multiple data sets, rebuilding any type of missing data, whether it be to keep the data itself or putting in information that's supposed to be there, standardizing the data, normalizing it, deduplicating the data so it can fit the data warehousing structure for each individual table, verifying that it and enriching the data, making sure it's proper, and then exporting that data so you can actually make your report, and then the process repeats itself and continues to go that way. Data warehouses may contain large amounts of data, so to be able to answer business decisions quickly, the queries made would have to be highly effective in pulling information, and how the data is processed is important as well. A little snippet from the article says that data warehouses uses redundant structures as indices and materialized views. Choosing which indices to build and which views to materialize is important physical design problem. The next challenge is effectively use the existing indices and material views to answer these queries. From the previous case where we were talking about the multidimensional table, looking at how that grid format was kind of set up, you can build multiple answers just from those three different dimensions, such as when a product would be brought in, how soon. It could be the sales behind it, how a product is performing in a certain region. Several questions can be answered, and a lot more can be determined using different types of OLAP processes. So, ensuring the way of inputting the data into a data warehouse and how it's structured is extremely important. The next portion will be proposed approaches and solutions. Ensuring the data is clean is a huge factor to the success of a data warehouse. Without clean data, there's no point into data warehousing. Throughout the years, there have been many advances towards data cleaning. My recommendation for an IT professional would be to go with a data cleaning software application to aid in the ETL process. According to the article, an evaluation on current research trends in data cleaning on data warehousing, there are a few different cleansing approaches that already exist, and here's a list of a few of them below. There's the FRAQL, Ajax, Porter's Wheel, ETL, and ARKTOS, Arctos. Um, Specifically for the FRAQL, that software actually has several beneficial features when it comes to the ETL process. A few of them to name would be it has a very transparent access to external sources. So whenever you're looking at how the information goes from that system to through the cleaning process. It's very clear of how that's actually established. It also has a integrating relation feature where basically it takes um, different information from different sources and actually uses joint and union operations to kind of resolve some conversion or mapping functions for advanced schema transformation and transpositions of relations, as well as resolving the matter of level of conflicts. It also has a feature where it resolves data discrepancies, instance of level conflicts. So depending on what level any information belongs within a dimension or a subdimension. It also uses reconciliation functions as well as user-defined aggregates and functions for that specific software. The next step would be when dealing with large amounts of data, going into a data warehouse, there's a few things that you must take into consideration. And to do that, you must ask the following questions. How much existing table is going to be in the database? How much existing records are going to go within each data, within each table? How much existing hard drive space is going to be currently used for the project? What's the growth rate of the project? What are some external data that we'll be gathering, whether it be from corporate/government entities or data direct downloadable sites? Determining what type of database management system that you'll use during the project is critical when it comes to answering those questions that we asked before, and critical to the design of how the data warehouse will be established as well. Right here is just a quick chart kind of showing you how a database goes into a database system, and then how you can use APIs to go into applications, users, or other applications, and that process could also be done the other way around, collecting all that information and putting them into a certain database system and collect information to put in the database. And here for the conclusion. In conclusion, data warehousing and online analytical processing are crucial details when it comes to decision support within the data side of a company. There are several things to take into consideration when establishing a data warehousing and OLAP technology, such as ensuring that you're inputting clean data into your database and what type of data schemas you're going to be using, as well as the type of database systems you'll be utilizing as well. All these factors and more are important building blocks to establishing a successful use of companies' data to help drive them to become more efficient. Here are my references, and thank you for listening to my presentation. Bye-bye.